Hi, this is Robert with RetroBasic.com. Today, I loaded MR Keno, and I was looking at the basic, and it looks really confusing. So what I've done is I've decided to explain it. I've got it here on the screen, and you'll just watch along as I explain what the lines of code do. Some of them are very simple. There's MR Keno. These are remarks. Original 1971 G.W. Fleming. And then we have a poke code. This one loads the sounds into the system. I'm going to rename that to be load sound. So when you type load sound, it would actually run poke 36173. That's 36173 is the control for everything. So I've got hundreds of commands that stem from that. The @A is it homes the cursor, clears the variables. It does a lot of stuff. It's like an all-in-one command. CLS clears the screen. We dim our arrays. Print at 4,0. RetroBasic.com, and these print statements I'll just whiz through. Now this command here, this one right here, wait any key, is a little sub-program that sits in one place until you press any key. And we have the print for the title, Keno. And we have, do you want instructions? Yes, no. Input D string, if left string, D string equals no. 145, so it skips all this stuff. These are the instructions, print, print, print. When it gets to enough on the screen, it does the wait any key again. We will choose 20 numbers from 1 to 80, and I'll show you how that's done in code. Let's see, type 99 to quit. Good luck. And here we are at the skip around the help screen at 145. Do you want to continue an old game? How many turns did you already use? How many dollars were left? It's inputting ES, and then it inputs T2 for how many numbers do you want. I'm skipping some of the code because it's very simple. The complicated stuff is going to get it's pretty bad. It's terrible. We input T2, and then we start. There's input T2. Then let's see. If T2 equals 66, continuous play is on. That's a 1. If T2 equals 66, then 299. So we're going to skip something. Then these are the inputs for your numbers. It's a A1, A2. It's an array from A all the way to 15. It's done like this because this is the way it was done in the original code, and I left it. But yeah, it's a mess. It should just be a for next loop, with that for next going only from 1, 2 to the number of you picked. And then it would be 4 lines of code. It would say he wants 15 numbers for x equals 1 to 15, and that would be easier that way. But this was made back when circles were invented. So okay, at 229, there's a R to T minus 1, and an M equals R plus 1 to T. If AR equals AM, then 255. All that's doing is going through all your numbers. It says he could have chosen a 1. I wonder if he did. His choices are 1, 2, 3, and he goes, it's a 3, it's a 4, it's a 6, it's an 8. Okay. All it does is detects a repeated number, like if you typed in 11 twice. So it says check for repeats, and if the number is too high, if it's greater than 80 in line 236, you have duplicated numbers, and you have a number too large. Now the computer is going to select its 20 numbers at random. This is a mess. This is a really hot mess. Because right here, let hx equals int rand 1 times 80. equal y is 1 to x minus 1. It's picking a random, and it's going to go to the random number minus 1. Now this command here, it looks like just a let a equal a. I don't know what that does. A is the array, and a is supposed to be an array, so let a equal a. I don't even know what that does. Maybe it did something on the old machines in the 70s, but who knows? Now, if hx equals hx minus y, then let hx equals, it chooses another random, and it backtracks to let a equal a at 325. That prevents you from getting a duplicate random number, so it can't choose randoms too. You have 370. It's going to locate. It's going to print L string. L string is how you're doing. It's when you're running the game, and it says how much money you have and how many matches you had on that round. Now, this is where things get... oh, yeah, we're going to go through what you picked. Look at the H array, and if your pix equals H array, then 428. This gets kind of scary. 428 says there's Q amount correct, so I add 1 to that. A poke statement here is a, remember 36173 is my place to go. It's a sound, but 247 plays that sound, and it's going to play number 3, and I poke that in one place ahead of the other one. So in other words, it's play sound 3, and I'm going to encapsulate both those commands into play sound and the number, and then you'll enter 3. So it does the whole thing in one step, in one command. But right now it's just this, I'm adding features to the core inside, and it takes a while. Okay, so it has determined how many you had right. This 435, this loop here, 1 to n. Oh, okay. This is one of my pieces of programming that I added. It creates the disks for the graphics, because it didn't have any graphics. Believe it or not, the original was. So everything at 435 to 440 is, I'm creating graphics, and you'll see that I put most of my code below theirs. It's Go Sub 4001. That's where that is, where it draws the little yellow circle. In 445, we wait any key, set text color. Now, I have a remark statement there that tells you set text color green, and then it's got there. Well, this is different. This is actually a machine code program. Sys 49360. You set the color 3 at 49361, poke 3, and then you call the machine code. It basically turns the whole screen backdrop green. Well, your character will look green in color. It's not the background. I still don't think I have a way to put a different background in. But, yeah, I do, but it's being worked on. Then we're going to determine the odds. Now, you'll notice if Q equals 1, the winning is 3 times the amount of coins you chose, so you get $3. If you have chosen 2, if n doesn't equal 2, skip that. Okay, if you chose 2 and you got both the 2, you get $12 times 2, which is $24. And, you know, the odds of getting that are really... That's why I don't play 1 and 2 and 3. And 3, if you'll notice, I believe I changed the odds, the 43, because it was so low. I thought, well, if you've got 3 choices and you got them all, you should get 43 times. It sounded like a good winning there. And all these were so low that I added stuff onto these winnings. Here's n equal 5, and that's almost $500 for getting all 5. And then you have 6, you get Goes up, and 5,000 if you get all 7. And there's 8. Like I said, this is just the winnings totals. And it goes all the way to where you've chosen 15. And if you get 15 right, 45,000. That's a lot, but that's it's impossible. And then it's going to say what the numbers the computer chose at 1900. And then subtract bet, so it takes away how much you bet, adds your winnings right there. It'll tell you you had a Q amount right. Press any key, quotes, wait any key, pause, clear screen, go to 170, takes you back to the start. Now if the money was down to 0, it says come back, bring more money. Now everything after 2500, that end command, this is my stuff. Make special characters for Reverse game. That's Othello. I'm working on that. That's a side thing. It'll be done. The secret place in memory where these characters go is 36,001, and we have 8 characters made. 11 characters made. You will see that they're in data here at 3200. There's my characters. And then to place them on the board, that's 3400. You're going to have a color code, CO. You have a base for your characters, which is color base, and it's set to 36,000. And there's 2 loops. All it needs to know is N2 and N1 are X and Y, and it's going to leap onto the screen to where it goes, and then it draws the characters with 3560 poke, PS, which is the screen position, YY, that's up and down, times 40, XX is your over and back, and it pokes 2 characters for the bottom of the circle, and then you have a color, and it's poking 2 for the bottom. Where does it put the top of it? Oh yeah, I think the next YY shoves it over and it draws. That's interesting. That's a little, I've confused myself here. Then this is drawing the place. Oh, wait a minute. Maybe this is the number. There's a way it place numbers in the board. So it's gonna put 10, 11, 12. These are the numbers. This is the draw placed piece that you've chosen at 3600. It's the same loop, but instead of drawing 2 numbers, you'll see at 3660 it's poke, character screen, TY, times 40. Whenever anything is character screen with brackets, TY times 40, that TY goes down 40 characters, so you're thinking rows. So row 1, 2, 3 has to go down 40 characters to get to the next one. That's hard to understand if you're brand new to screen graphics. But you can see that then the X value, and I always get X and Y mixed up. I like using X for row, but in this case the X is the column, and all I do is print one character, TX, column, and then the second character is TX plus 1 over 1 column. And then the same thing with the color, poke, CS. Why would it be CS if it's character screen, color screen? Oh, because there's 4 pieces to the little circle. It pokes this one, that one, and then this one, that one. And here's another sound call. Remember 247 is call sound. It plays 0, 1, or 3 depending on a random kind of thing, and it makes a lot of noise doing it. We're almost done. Draw, place. Now this draw, place for the pieces, this is for the computer's pieces, the 20 he's chosen, and it's just, it's a hot mess. It has to count with M2 equals M2 plus 1, and that's what was I doing with that? Oh, it's just to make the row go down 10, and then when it gets to the 10th one, it does its last print, and then it shoves it to the 11th chip, and it goes down, 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 down to 15, and down, down, down to 20, shoves it back up to 21. That's what M2 and variables N1 and N2 do. And then you have the same pokes for the 2 pieces of the disc on top, and then the 2 pieces of the disc on the bottom. Oh, and this is especially, you'll notice in the code, if you're new to everything, which I am too, but CO right here is the color. So it's poking a character data in. That's weird. Well, I thought my color went in. This is color plus 10 times 16. So if you have a byte of 8 digits, 16 automatically puts a number 1 through 15, shifts it up to the top 4 bits to make it 16 times higher than the lower bits. So the color is being put in the higher bits. And my character data goes in, and I thought I had that. Some of the concept there is good to learn, but the color I usually put in the lower 4 bits, so maybe I added everything together and did everything. Yeah. Well, maybe that code, we'll go over it later, because we're almost done here. Place in memory the player's pieces. 35,000 is and 1 is the color area, and you're going to have 920 characters on the screen. I don't use the bottom 2 lines, so those I don't need that. So for DE, which is going on the screen, DE is at random. You're starting at 35,001 for all character and color data, and then it's moving. This part is kind of weird. It moves all the data over to 37,000. Just loads it from 35,000, moves it to 37,000, and you could instantly save the 37,000 bank to memory. In fact, one of the times I did that. But now that memory saving, here is the saving commands. They've already been changed so they don't say peek poke, peek poke. Save slot 99. I've got 1 to 99 save slots. You can save any amount of memory from RAM to the hard drive, load any amount of memory back to RAM from the hard drive. You can actually save the whole program you're running. It would probably crash though when you reloaded it. I actually don't know. This just, you would save 1,000 characters and then it would load 1,000 characters. With the other command, load slot 99, load data 35001, load length 1000, and then load data do, which activates the command to happen. And that's all of the code. I know it seems like quite a bit just for a Keno game that's putting little circles on the screen. But when you break it up into little portions, and that's how you, if you were starting out, you should break everything down to 1 line. Tell yourself or write down on a piece of paper what you want a line to do. And then look at a variable and see how you can make that variable do what you want, whether it's inputting characters, inputting numbers, doing screen text or graphics, and take it one step at a time. You'll be able to make some amazing programs there at the, once you've learned. In fact, any skill I've ever grabbed onto, except for when I learned Visual Basic. I learned everything in 2 weeks. I was in college, I borrowed a book, I went through the whole book in 2 weeks. And I learned Java about 3 weeks. But with this basic, if you're brand new to it, I would give it 3 or 4 weeks. Just program a few things every day, like for an hour, and don't just all of a sudden get flustered and say, oh, this ain't for me. I think every programming language is more complicated than basic will be. And if you're born to be a programmer and you want to see something happen on the screen that you've done, The payoff is always worth more than the amount of effort. Even though sometimes the amount of effort is you have to get together with people and maybe go on the forum and ask a question or leave an email to me, or maybe read the manual even. We're going to make an impressive manual, but designing a manual is and make it look pretty, nice, presentable, fun to read, easy to understand at the start, and to do one properly, I have found it's a big chore. So I'm nowhere near done with the manual. I have some help files that I want to put on retrobasic.com, which go over the commands in general and show some listings of what they do, like examples. But yeah, Mr. Keno on GitHub. If you'd like to see more, I am doing a special with Patreon. I'm going to make a video in the next week or two called the Golden Patreon ticket. It'll be a code. It's going to be good for life. So if you signed up now, and the channel kind of is sweltering because I'm running out of my savings. And if you were to buy a token for this golden code, you would get 2 codes. You have to be a Patreon for 1 year for it to go golden. But if you sign up now, once I get enough people to pay the electric bill and such, the offer's over. So it'll be about 60 to 90 days. I'm hoping I can get 100 people. That's all I really need is 100. And it's a mountain to get 100 people programming in BASIC that want to do it so much that they want to see these videos. And but yeah, once I get to 100 and the 80th or 90th day hits, I'll shut down the golden code. You'll have your Patreon code, which will work while you're on Patreon, but you will have your gold code. So you could get rid of Patreon, and your gold code will run any of the programs, any of the tools, and anything for life. And if you give up on programming in BASIC, you can sell the gold code to someone. The security for the codes is going to be, if it's signed in one place in the world, it's legit. But if it starts showing up as 4 and 5 different people in one area, and your code has been shared, in other words, the code gets invalidated. So you don't want to let that happen. But yeah, you could sell the code to someone else and But I think what it costs to get in is so low, and I will be working full time to add features to this, and also making Retro Basic 2, which I'm trying to make it more powerful, easier to use, and even better than Retro Basic 1 is. So that ought to be a big thing to hang on for. Watch the videos, check out the website, and check out GitHub from time to time, see what I've added. But you guys have a great day, and thank you for watching.